Welcome to the Automate Workshop. Hi, I'm David. In this Fundamentals module, we'll be looking at the low-speed bus. Bus technologies have made many advancements over the past few years and will continue to do so. Understanding how these systems work is key to you being able to diagnose them. BUS is an abbreviation for Binary Unit System. It's a network system used within a vehicle to allow modules to communicate and transfer data between each other. The information is sent in the form of digital code from the sending module and decoded by the receiving module. The bus system has many advantages. More module controlled functions are included in the modern vehicle. The bus system allows locally placed modules to do the computing. This reduces the number of wires required. The system is also more reliable as there are less connectors and wires to develop faults. And the information can be sent in two directions on the wire instead of just one, as in the old networks. There are many different types of bus systems. We can have high speed, mid speed, low speed, chassis expansion, powertrain, optical, and LIN, or local interconnect network. A modern vehicle could have all of these systems or just a few. We'll be concentrating on the low speed bus for this module. The circuit and waveforms shown in this module are typical of many vehicles. Always remember to check the appropriate data for your vehicle. There are several different types of topology or layouts for bus systems. This is a mesh topology. As we can see, every module is connected to every other module. It's fairly complex, requires a lot of wiring, but it is almost impossible for communication to be lost in these modules. Here we have ring topology. All the modules are connected in a circle. And because we have two-way communication, if there is a break between two of the modules, they can still communicate with each other. It requires two breaks to prevent communication happening. Star topology is one of the common ones we use in low speed. As you can see, all of the modules are hooked up to a central point, or a star point. If any of the wiring is broken, it will cause a loss of communication. Linear topology is mainly used in high-speed bus. As you can see, all the modules are connected in a chain. The information goes into and then out of each module. If there's a break in the wiring, one or more modules will stop communicating depending upon where the break is. In bus topology, there are two main modules connected to each other. All the other modules are attached via this connection. The most common types used in low speed are ring and star. Ring layouts are either single or multiple. This is a double ring layout. The body control module is the common point for both rings. One module is normally a gateway. This allows transmission of data between buses. In this case, it's the column integrated module. It's connected to the high-speed bus as well as the low-speed bus to allow transfer of information from one to the other. This circuit shows a star topology with no gateway. So the information on the low-speed bus has no way of getting to any other bus. This is a star topology with the body control module being used as a gateway. The body control module can now allow data to transfer between the high-speed and the low-speed bus. There is also a removable star point, often referred to as a removable splice. This aids us in diagnosis. The low-speed network uses a single wire because low data transmission rates are used. This is a typical low-speed network signal. The voltages can vary between manufacturers. The voltages don't really matter. It's the on and off pulses that provide the information. In this pattern, it can be seen that the 4 volts is the 0 and the 0 volts is the 1. This will depend upon the system and may be the other way around. A typical data transfer rate for a low-speed bus is 33.33 kilobytes per second. Electrical interference can cause a breakdown in data communication on the single wire network. But because the data is sent slowly and at low repetition rate, the data can be sent again when the interference stops. That's our overview on low-speed bus networking. As you've seen, there are many variations from vehicle to vehicle, but the operating principle is still the same. The low-speed bus network is very reliable and not difficult to diagnose if you know how it works. This module was designed to give you that working knowledge, to help you with any low-speed bus problems. And always remember, training is the key to your success. Bye for now.